We are going to pick up right where we left off yesterday from Thursday. Today is Friday, and we are going to find correlation. So we had just done that scatter plot. We talked about how to describe it, and now we're going to calculate and describe correlation. So maybe pause the video, type all that data into a list. If you need help finding that data on your calculator, get that on one screen for you. You want to go to a spreadsheet on your TI Nspire, and you click down here on that spreadsheet, and you name the list. You can be fancy and call this points. I just call it A. And for column B, for the wins, I called it B, and start typing. So back to the list of data. Type all that in real quick, and I'll show you how to do it on the calculator. So on the calculator, I make sure my cursor's up here, not way down here, or I won't be able to see what it outputs. And you go to Menu, Stats, Stat Calc, and you have two choices. Both of them will work. I like to pick option 4 because I know it sounds weird, but in stats, we're going to use B to estimate the slope. I know that's weird because in Algebra 1, B was the y-intercept, but in here, when we do hypothesis testing about the slope, we use the Greek letter beta, which then goes hand in hand with a lowercase b for the sample slope. So I pick 4, although if you accidentally pick 3 right there, no big deal, you'll get the same answer. Just your letters will be different. For the X list, type in the name you named it. I named it A. For the Y, I named it B, and tab down to OK. And there it all is. These first 3 we'll talk about, let's see, the next 2 we'll talk about next week in equation for the line of best fit. And then we'll also talk about R squared. And today we were talking about R. So yes, R squared is the square of 0.9359. It's easy to mix up the names of the two. Just plain old R is correlation, and R squared, it's called the coefficient of determination. We'll do that next week. All of them are super important. This next one down is super important. If you're holding a TI-84, they're stored under lists, these residuals, and we'll talk about those. But today, just R. So 9359, remember that number. All right, back over here, let's talk about correlation. So correlation communicates 2 things to us. It communicates what direction is the data moving, is it positive or negative, and how strong of a linear relationship. It does not measure curvature or any other function. It only tells you the measurement of the linear relationship. And if you think for a minute, a calculator, a formula, I think I have the formula at the end of the slideshow. It's not psychic. It doesn't know if there's curvature in the plot. So for example, let me purposefully draw some slight curvature in a plot. I think that's good enough. So while you could maybe argue linear, I think there's curvature there looking like it might be an exponential relationship. I don't know. We'd need to take a bigger sample. But if I were to sketch a best fit line through there, those dots are very close to the line. I bet you would get a strong correlation. So here's the deal. Correlation, it doesn't tell the whole story. It's one tool to describe something as linear. In this case, that tool would not be useful. All right? Usually the scatter plot is the most useful tool you have. And right here, the scatter plot tells you it's not linear. All right, we'll talk more about that on the next slide. I mainly wanted to point out that it is a measure of the linear relationship. Okay? All right, more about correlation. Here are some different possible values for R. And by the way, if you don't know it, R must be no lower than -1 and no higher than +1. Closer it is to -1 or 1, the stronger it is. The closer it is to 0, the weaker it is. And I'll give you a nice number scale to use to describe weak, moderate, or strong. So I hope those graphs make sense to you. The closer the dots are to each other and the linear pattern, the closer it is to -1, bottom right, or the closer it is to +1, bottom middle. And then as they spread out more and more, R moves away from 1 or -1. This one, I hate that they say exactly 0. It's never going to be exactly 0. It's approximately 0. And I don't know why they even included this dot up here. They should delete that dot. Maybe even that dot. And then definitely 0 correlation. But then again, it's a formula and it's going to give you a value. Most likely it won't be exactly 0. So, all right, moving on. All right, here are some facts about correlation, things to keep in mind. Technically, the name is correlation coefficient or Pearson's correlation coefficient, but I always just call it correlation. Something interesting, it does not know the difference between X and Y. You could literally flip X and Y and you get the same exact R value. If I look at the formula on my formula chart, look at that formula right there. This looks like a z-score for X, a z-score for Y, and they're doing each individual z-score for every single coordinate and multiplying the two z-scores. So if I was to flip the X and the Y, it would make no difference. I would get the same R. All right, what else? If I have measurements, say in feet, and I change it to inches, no change. R does not change. R doesn't even acknowledge measurement. It has no unit of measurement. It's just a measurement, only a measurement of linear strength. And I already wrote the blank for the next one, but I'll write it again. Must be between -1 and 1. And let's do a number line to help guide us in describing that strength. So if you have colored pencils, this may be a time to break them out. So there's our number line. We're going from -1 to 1. And here's 0, 0.5, 0.8, -0.5, -0.8. So the closer it is to -1 and 1, the stronger it is. So maybe let's say 0.8 is our cutoff. And let's call that strong. And then if it's in the 0.5 to 0.8 range, let's call that moderate. And then if it's between -0.5 and 0.5, let's call it weak. And I gotta be honest, AP doesn't really care about the details of this number line. If someone was to call 0.75 strong, they wouldn't care. If someone was to call 0.4 moderate, they wouldn't care, I promise. They're more worried about you using the right language in terms of, say, describing its strength and describing its direction. Now, if you were to call something like 0.1 as strong, they might not like that, so that would be bad. But this number line, this guide is from an old textbook I found. It's actually not even typed in our new textbook. They usually just guess, they eyeball it. So, all right, I think you guys know the next blank. Correlation does not imply causation. And let's see, both have to be quantitative or numerical. You can't do this with categorical variables. That's a whole other type of model. If you're clever, you can make categorical or qualitative data quantitative, but we're not going to go there. We're not going to do that. Correlation does not describe curved relationships. So yet again, if there's slight curvature, the formula R has no idea. All it's doing is measuring how close the dots are to a line. All right? A value of R close to -1 doesn't guarantee, I just said that. So hopefully that makes sense. All right, let's wrap this up. 7th period is about to walk in my door, so I have to talk fast. We are skipping this today. We'll talk about it later. But let's define the SEC data, the football data. Let's define its R, its correlation. So I've already forgotten. It's like 93 something. Let's look. 93.59. So let's do it. For the SEC data, R was 93.59. And you want to use context, direction, strength, and then you must say linear relationship because it is a measure of a linear relationship. Even if the scatter plot is curving, R is a measure of linear relationship. So for the SEC football 2011 season, points per game and wins have a correlation of 93.59. They have a positive, there's my direction, strong, there's my strength, linear relationship. Other than context, the only two words that are going to change, context of course will change, but the only two other words that will change are positive and strong. When I'm describing correlation, I'm always going to be talking about their linear relationship. All right, next slide has some formulas that we will talk about next week. They're like alternate ways. Maybe you could use a system of values to figure out what R is or what the slope is, but that's about it. See you in class. Bye.